More use of timer instructions, sequencing lights. In this section of labs, doing some more with timers, the first one that we had was a free running timer. We have one rung and we have a true if off done bit for T40, and then we are using that to enable T40, time base of 1/100th of a second, preset of 1000, so that would be 10 seconds. And this is really simple. I call this free running because it looks like it counts up to 1000 and then starts over again. And it does actually do that because when the accumulate equals the preset, the done bit comes on, and the next scan around, that instruction at the front of the rung, the true if off, is now going to be false because that done bit is on. So it's going to execute the false execution for that TON instruction that's addressing T40. It's going to clear everything. And then on the next scan around, because the done bit is now off, this is true again. It starts all over again. Now, if you were asked the question, remember this is a 10-second preset, 1000 times 100th of a second. If you were asked if after 100 seconds will this have made 10 complete cycles, that would not exactly be true, because remember that you lose one program scan while the done bit is on. So it times for 10 seconds, then it's off for one scan, then it starts over again. So you would lose about 1,000th of a second every cycle. Well, that's not much, so for all intents and purposes, you might as well say that it's free running. Hence the questions, is this rung always true? Think carefully before you answer. No, it's not always true. Why? Because the done bit is on for one scan. Otherwise, if the done bit did not come on and make the rung false, then this TON would never execute its false execution. What resets the timer data type T40? A true to false transition of the rung. Then we had you add a branch around T40, or the TON addressing T40, and use T40's done bit to enable T41. Notice also that our condition on rung 0 there, the true if off, is now T41 and not T40. So when you start off, T40 and T41 have an accumulative 0, and neither one of them is done. Therefore, T41/done on a true if off is true. It enables the timer data type T40 and starts accumulating. It accumulates for 1 second, turns on the done bit, and that done bit then starts another timer, T4:1, for half a second. And then when it's done, the rung goes false and it starts all over again. So now you're cycling between T40 and T41. So you have done bits that are coming on at different times, and you have, more important than that, you have timer timing bits that are not on at the same time. So in this case of the done bits, when T40 is done, then it enables T41. And there will be one scan where both done bits are on. You can see that. I mean, you can see the logic of it, even though you can't see the done bit for T41 going on. If it's not going on, then you would not reset this rung. Do both timer data types accumulate simultaneously? No. How long is T40 not accumulating? It's not accumulating for half a second plus one scan, but we'll say a half a second, 500 of a second. How about T41? How long is it not accumulating? Well, T41 is not accumulating while T40 is accumulating. So T41 is not accumulating for 1 second. Watching your logic in the remote run mode, does the bit T41.done ever go true? Yes. Why do you see the done bit in the T1 instruction addressing T41 go on? The done bit in the T1 instruction addressing T41. We're talking about T40 done bit. It's the one that is enabling the TON instruction addressing T41. You see it go on because it's on until T41 times out and clears the rung. So you see the done bit on for half a second at a time. Basically, it's only on until it's done, T41 is done, and then that clears the rung. So you could say that T40 done bit is on for the same length and during the same time as the timer timing bit for T41. That wasn't in the lab, but that's noticeable. Okay, add some more logic. With input 0 on, what you're observing is that the timer timing bit from T40, which is on for 1 second and off for half a second, is what is driving output 0. So your light on your digital field device simulator, output 0, that light is on for 1 second and off for half a second. Now, if I flip input 0 off, it looks like the same thing, but it's not. Now, the timer timing bit for T41 is what's driving the light. So that light now, or that output 0, is on for the preset of T41, which is 1/2 a second, 50 hundredths of a second. And then it's off for 1 second, on for half, off for 1 second. What idea you could get from this is if you have a light on your process or your machine that you want to flash, but you want it to flash at different rates, this is how you could do it. Just use some method of selecting which timer timing, if you want to call it pulse or interval, is actually driving the light. The question was asked while observing output 0, is the lamp energized longer when input 0 is flipped to the on position or the off position? Well, when it's flipped to the on position. Why? Because the preset, hence the timer timing bit, is higher or longer than that for T41. So T40 has a longer preset than T41. So in the on position, now we're using the longer pulse to drive our light. Quite often, this is how I generate a pulse. Is in the duty cycle here, is if you want to say it's 60%, you could say that. Well, it's roughly twice, or out of 150 seconds. So the whole cycle is 150 seconds. 100 preset for T40 and 50 for T41. So out of a 150 hundredths of a second, or 1.5 second cycle, it's on for 2/3 of that time. So it's a 2/3 duty cycle. If I were to change the preset here to 10, it's still on for 1 second, but it's off for 1/10 of a second. If I flip the switch to the off position, then every 1 second I see a quick little blip. So you can see how playing with not done to enable a timer, and when that's done, it enables another timer. In other words, you are chaining the timers together. So when one's done, another starts, and another starts, and so on. All kinds of things you can do. I'll bump that back to 50. We changed the logic a little bit. We added another use of another timer data type, T42. So we have 3 TON instructions. Enable the first TON instruction that addresses T40 with a preset of 100 or 1 second. When it's done accumulating, it enables T41 for half a second. When it's done accumulating, then its done bit enables T42 for 1 second. When T42 is done, its done bit, which is used in the true if off at the beginning of the rung, goes false for 1 scan. Next scan around, it starts the process all over again. So if you watch the accumulate values here, you're watching 100, 50, 100, 100, 50, 100. So we've cascaded 3 TON instructions together addressing 3 separate timer data types. If you had not changed the true if off from T41 done to T42 done, that would be this guy right here. if you had not changed that from 1 to 2, would T42 have been enabled? The temptation is to say no, but the answer is yes, because this is scan left to right, top down. So on the scan, when the cumulative equals the preset, the done bit is turned on and enables this timer, but less than 1/1000th of a second later, it clears the whole rung. So you're never going to see it accumulate. So how would we prove that T42 is enabled? Well, you see right there, we didn't do this in the lab, but you've learned how to create a bit trap. So just to verify this, I'll toggle this, and you see it latches right back on. So I'm going to toggle this off right when T42 is complete or done. Well, it never starts. That's right, because we changed that to T41 up there, the true if off at the beginning. So when T41 is timing, I'm going to change this. Better yet, I'm going to change it when T40 starts. See? So you see it being latched. So the gotcha bit here goes on. That proves that T42 was enabled because the rung was true. So this was true, enable the timer. One scan later, this is false and resets all three. So I'm going to take that back out of there. That does not belong in there. But just to show you how to use a tool you've already learned about. Okay, see, we changed the logic. We added the use of some timer timing bits. And by the way, those timer timing bits and outputs don't have to be in the position shown. You could have added separate rungs. In other words, you could have went down here and put in a rung looking at a timer bit and turning on and out. But we've already used these outputs, so we'll use 3. And we'll use this timer timing bit right here. I see it, so I just drag it down, finalize, and you see that light number 3 or output 3 is on at the same time as output 0. So I tend to compact everything together in one rung if I can, just to make it easier to analyze. Because if you were looking at this rung by itself, right here, you haven't the biggest idea what's controlling T40. Correct? I mean, that could be in another program file someplace. It's in the same controller. It's being executed in the same logic, but it's not right in front of you. So you can't see what is controlling, enabling, resetting, if you like, T40. But if you put it right in the same rung, then all the logic is apparent. I'll delete this. We don't need that. So I tend to combine the logic all into one rung to make it easier to troubleshoot. If you converted all of the timer timing bits that are controlling the outputs to done bits, describe the sequence that you would observe. We'll just do that. So we'll make this the done bit, make that a done bit, and make this one a done bit. Okay, right now it's still behaving with the timer timing bits because this is the rung that's being run. See the green R's in the edit zone? And because this is an offline project animated by the online data, these outputs are still behaving the same. 1 second, half a second, 1 second. Now, when I finalize the edits, because you're using the done bit instead of the timer timing bit, then the output 0 is not on while T40 is timing, but it goes on when it's done. Also, when it's done, it enables T41, but output 1 does not illuminate while T41 is timing. It doesn't come on until it's done. And then when it does come on, that enables T42. And since we're not using the timer timing bit, output 2 appears never to come on. But you know from the previous lab that actually output 2 is being energized, or that bit addressed by O:0.0/2 is being set to 1 for one program scan. Next scan around, the rung goes false and clears everything. How long would output 2 be eliminated? Well, one program scan. If you wanted to say how long would the bit be on to be one program scan, would the light ever be illuminated? If you apply power for less than 1/1000th of a second, there was current there, but it was never illuminated in the sense of seeing light. This is referred to as cascading timers. What bits you use to control outputs, that's up to you. You can even compound the usage of these bits. For instance, I'll put this in the edit mode and I'll put in a true if off. Then I'll use T41. Throw it up there, finalize. Now you see output 0 is only on for half a second, because if T41 is done, that's a half second has elapsed. We see output 0 on until output 1 goes on, and then they're both off. They're both on for half a second each. Now, why would you do this? I have no idea. But this is meant to show you how you can use the control bits to time situations or create pulse trains. I'm going to delete this instruction to put it back the way it is in the manual.